Hello friends, today we are dealing with the third module of statistics, that is dispersion and measures of dispersion. In this session, we are detailing what dispersion is and discussing the measures of dispersion. So I think you are all familiar with the word dispersion, especially in physics. In physics, dispersion is the splitting up of light into its constituent elements. Let's see what is the context of dispersion in statistics. Towards dispersion. As we all know, the most popular data analytics technique in statistics is the mean, median, and mode, that is the central tendency measures. So, why dispersion arose as an important concept in statistics as the central tendency measures exist? Let's consider an example. Table 10.1 shows the annual incomes of Group A and Group B laborers. Here, there are 5 observations in each group. So, let's consider the mean value. Let's calculate the mean value of these groups. And Group A shows the mean value 31,900, and we are calculating the mean value of Group B incomes, and that is also 31,900. So we found that the 31,900 is the common mean of Group A and Group B laborers' incomes. So here let's consider Group A. Here 5,000 is the lowest income and 85,000 is the highest income. And there is a huge difference in the incomes, and 31,900 considering 5,000 is a very huge amount. So, but when considering Group B, 20,000 is the lowest income and 40,000 is the highest income. 31,900 is almost the central point or average of these individual observations. So, but this 31,900 is not sufficient to represent the individual observations of Group A incomes. That is why dispersion arose as a concept, because here the mean value is not representing each of the values or each of the observations of this data set. So, when the condition arises where the data is biased, there is the necessity of representation of individual data, or to see how the data set is spread around a mean value. So, this is the reason for the emergence of the concept dispersion. Let's see what is in detail. Dispersion, as we already said, there is inequality among the values occur. There is a huge inequality occurs when mean is not sufficient to represent the data. So there comes the variation or dispersion of the data. It means the deviation of each individual values around the measures of central values. That means this is not totally neglecting the central value or the central tendency measures, but it is considering it and fixing it as a central point and see how the data is spread or how the data set is varied around that central point, that is the mean of the dataset. If the value of dispersion is less, it implies more reliability of averages. So, if we have a dataset, we are fixing the central point, that is average of dataset, and we are seeing how data is spread. If the dispersion is more, that means the spreading of data is more, then the average is less reliable. If the data spreading is less, then the mean value approximately represents the individual observations. So the reliability is take on the basis of dispersion. If the reliability of the average is high, that means the data is less dispersed. Then what is the need for dispersion? As we already said, dispersion is important for describing the spread of data or its variation around the central point. So, if we have two distinct samples that have same mean as we seen in the example table 10.1, but their spreading is very different. That means, as we already seen here, the group A has a very spreaded value. That means it covers from 5,000 to 85,000. So there is a huge dispersion or huge spreading of data. So this is the relevance of dispersion. In the next slide, we are going to discuss its importance. Importance of dispersion in general is it supplements the information given by central tendency measure. As we all know, the dispersion is not entirely neglecting the central tendency measure. It is fixing the it needs the central tendency measure to fix the center or fix the average, and it is seeing how the data is spread. So it is supplementing the central tendency measure. That means it needs the dispersion needs the central point to see how the data is spread. That is, it is supplementing the information given by the central tendency measure. In the second point, it is saying that measures of dispersion make possible comparison between different groups. As we all know, if we get a data set, then we can compare the spreading of data. If we are comparing the data by analyzing the spread of data. So while analyzing the this data set with the technique dispersion, we can see what is the extreme value of a particular data set and what is that of another data set. So we can compare the data sets, and measure of dispersion are very important in many social problems, especially in the as we seen as example the incomes. It may not represent the individual incomes, so it is the division of labor, etc., are very important social context where dispersion is used. The then the last point is measures of dispersion serves as useful check on drawing wrong conclusions. But as we said, it is very efficient in comparison. We can avoid drawing wrong conclusions or reaching at wrong conclusions by using dispersion. In the next slide, we are discussing the importance of dispersion in research. So in research, we are using wide variety of statistical techniques. Dispersion also has a relevance in research. So understanding variability. Once if we get a data, we collected the data for research purpose, we have to identify the nature of that data, and we have to analyze how the responses vary. What is the especially if we are considering the rating scales like Likert scale or 5-point scale, we need dispersion to see what is the extreme opinion and what is the extreme opinions, whether it is positive or negative. We have to see extreme opinions, opinions that lies in between. This etc. can be understood from the dispersion technique. Then second one is outlier detection. Then what is outlier? Outlier is the extreme values that is shown in a data set. That means if 5 is a central point, then minus 5, that means minus 5 is the least value of that data set. Let's imagine. Okay, so minus 5 is the smallest, and 15 plus 15 is the highest value of that particular data set, and we are fixing 5 as the mean value. Then minus 5 and plus 15 are the extreme values, and they are the outliers. All other data are in between this two extreme values. So the 3 by 4th of the data is spread in between the mean central point, that is 5, and minus 5 and plus 15 is spread widely across this central point. So minus 5 and 15, that means the extreme values are the outliers. So we can see how the which are the outliers of a particular data set. Then third one is comparative analysis. As we already said in the general importance of dispersion, it is helpful in research also for the comparative analysis. Then fourth one is survey reliability. As we already discussed about reliability and the relation between reliability and dispersion, it is important. If we are considering survey as a method for data collection, then we get the different wide variety of responses from the samples. So, if the data is spread widely, that means we got a mean point of that responses, and some data is seen spread widely spread from that mean point, then the survey is less reliable or there is an error in our data collection. This can be understood with the help of dispersion. Then the fifth point is descriptive statistics. Dispersion measures like standard deviation and quartile ranges helpful for summarizing the context, helpful for summarizing the responses and giving it a context, that is descriptive statistics. Then testing hypothesis. As we all know, dispersion is useful for testing hypothesis. It is very relevant in research. So we are completed the first session, that is dispersion. Now we are discussing the second part of our topic, measures of dispersion. There are many measures of dispersion, or there are many tools to measure the dispersion rate. Here I am discussing with you the five prominent measures of dispersion, and there is also other measures like variance, design, etc. But in this session, we are discussing the important five measures of dispersion, that are range, quartile deviation, mean deviation, standard deviation, and percentile. So let's see what is range, or how range is a measure of dispersion. Range is the simplest measure of dispersion. It is defined as the difference between maximum value of variable and minimum value of variable. So, range is the first and simplest measure of dispersion. We obtain the value of range by finding the difference between the highest x value and the lowest x value. So, let's consider the same example as we previously discussed. Group A, the highest value of x is 85,000 and the lowest value of x is 5,000. So the range of the group A income is 80,000. Similarly, we are calculating the range of group B incomes with the equation x max minus x min. We get that 40,000 minus 40,000 minus 20,000. So the range is 20,000. The group B range is 20,000 and group A range is 80,000. So we can see a huge difference in the ranges, in these ranges. We have already seen that the mean value of this group two incomes are similar, but we observe now that there is a huge difference in the range value obtained by these two groups. So the highest range value shows that there is a huge dispersion in the data set, and the lowest range value suggests that the data set is less dispersed. Then let's go for the second measure of dispersion, that is quartile deviation. So as we all know, quarter means 4. So in the quartile deviation, we are measuring the middle set of the data's deviation. That means the entire data is divided into 4 quadrants, that is Q1, Q2, Q3 and Q4. In order to calculate the quartile deviation, we are subtracting the Q3, that means quadrant 3 value from quadrant 1 value. Quadrant 3 is the upper quadrant and upper quartile, and Q1 is the lower quartile, and that is divided by 2. So the QD can be calculated as Q3 minus Q1, that is the upper quartile value minus the lower quartile value, and that is divided by the number 2. So there is a problem arises how we get the value of Q3. Q3 value of Q3 is number of observations plus 1, and that is divided by 4. So we get the value of Q3 number of observations plus 1 and divided by 4. We get the value of Q3, and the value of Q1 is obtained by multiplying the number with 3, multiplying the value of Q3 with 3. Sorry, there is a mistake. That Q1 value is obtained by adding number of observations to 1, and that is divided by 4, and we get the Q3 value by multiplying the Q1 value with 3, and that is divided by 2. We get the quartile deviation. Next, we are discussing the third measure of dispersion, that is mean deviation. Mean deviation is used to calculate the average of absolute deviations of data from the central point. So, as we already said, the concept dispersion, mean deviation is to calculate the average of absolute deviations from the central data point. That means we fix a data point, that is the average, and we calculate how the deviations happen in a data set, or how the values are dispersed. So we fix the mean value and we calculate the deviations from deviations to each of the observations in the data set. We have an equation to find the mean deviation, that is sigma I is equal to 1 to 10 mod of xi minus x bar whole divided by n. Here xi is the observation, single observations, x bar is the mean of the values. X bar is the mean of the total x values, and xi is the individual x value, which is divided by the total number of observation, that is n. We obtain the mean deviation. If there is a huge deviation, if the value of mean deviation is higher, there is a high the spread or dispersion of data set is high. If the mean deviation value is less, then it indicates the more reliable average. That means less dispersed, more reliable central point. Now we are discussing standard deviation, which is the fourth measure of dispersion. Standard deviation and mean deviation is in a sense similar. That means mean deviation is used to calculate the is not considering the outliers, while standard deviation considers the outliers. Mean deviation is especially used that means in mean deviation, here the data the central point is fixed, and we see how the values spread over that mean point. That mean point is fixed, and how the values are spread across this mean point. So here the outliers are totally not considered. That means they neglect the outlier values. Mean deviation neglects the extreme values. It is only taken the central values, so the values that are spread around the central values, and it exceeds the outliers. So, but standard deviation is different. That means it is also the central point is fixing. It is also fixing the central point, and see how the data is dispersed from the mean. But here the standard deviation considers the extreme values also. That is the main difference between mean deviation and standard deviation. In mean deviation, they neglect outliers, while standard deviation includes the outlier values also. The mean deviation is used in the context of business, that is customer satisfaction. For example, if we are considering the customer ratings of a particular product or service, then they consider the extreme or the extreme points. That means if the customer rates too good or too bad, it is avoided or neglected. But they take the popular opinions about their product or service. So they took the take the tool mean deviation. But in standard deviation is used in the context of a classroom. A teacher a teacher considers the extreme values of the scores obtained by the students in an examination, because each student is valuable. So she considers the worst performed student and the best performed student. So there is an inclusion for the outliers, and that is standard deviation. Here we have an equation to find the standard deviation, that is root of sigma x minus x bar whole divided by n minus 1. So here x minus x bar whole square by n minus 1. X is the value in the data distribution. X bar is the mean of the data set. N is the number of observations. While getting these three values, we can see the standard deviation. For making it more clear, maybe there is a chance for confusion, because mean deviation and standard deviation is too resemble in their name and in concept. So let's consider an example for standard deviation. Here the age is given in the y-axis. Ages of people of a particular group of people is given in x-axis, and y-axis shows the number of people, or people identified in numbers 1, 2, 3, etc. up to 20. So 20 people and their ages are shown in x and y axes respectively. So we have to calculate the mean value, that is 19.35. 19.35 is the mean age of this group, and we are fixing it by drawing a vertical line, that is this point. So here we are considering how this mean value is representing the entire data set. Here the age of first person is 18, which is minus 1.35, different from dispersed from the mean value, that is 19.35 years. So from analyzing this, we can see that person 5, person 12, person 14 and person 19 shows less dispersion, that is minus 0.35 spread from the mean value, and 7 and 13 shows a higher dispersion rate, that is minus 2.65 plus 2.65. Person 14 and person 7 is dispersed higher. That means their value, their age is very distant from dispersed from the central value, is very distant from the central value, that is 19.35. So this spreading of data here, each individual ages are very important, and this spreading of data is an example for standard deviation. Now let's see the fifth measure of dispersion, that is percentile. Percentile is used when we need to compare the exact values of numbers over other numbers from the given data set. That is the accuracy of number. Percentile is used to compare. that means we need to compare the values. We use percentile. We are fixing a particular value and we are comparing how the values above that particular value and below that particular value is spread. So in the quartile deviation, we divided entire data set into four quadrants. Here we are dividing the entire data set into 100 quadrants. Okay, percentage is always related to the whole 100, and here in percentage we are dividing the entire data set into 100 to ensure the accuracy of the number. The percentile value, the main importance of percentile value is that the number is unique. So here percentile is equal to number of value below x. That means we are fixing a value, as I already told you. We are fixing a value, particular value, and we are calculating the number of values below that particular value, dividing that with total number of values and multiplying it with 100 to obtain percentile. So this is the equation of percentile. Let's see what are the steps of calculating percentile. Step 1, color the data set. That means we have a particular data set where the percentile is to be calculated. And step 2, arrange the data set in ascending order. So we get, if for example, if we get 10 observations, we are arranging that 10 observations in the ascending order of their obtaining sequence. Then in the third step, we are determining the total number of observations. So I told you we have 10 observations, so which are arranged in ascending order, and we are calculating the total number of observations, that is here 10. So in the step 4, identify the data value for which you are interested to find percentile. If there is an observation 70, then we are setting 70 as a particular value. Then step 5, count the number of data values that are less than the above value. So in the ascending order, 70 is the point we chose, and we have to count the number of data values that are less than the above value. So we have to calculate to the left side of the data set to get the number of values. Maybe it is 3, 4, maybe three data values are lying left of 70. We have to, so the count of number of data value is 3, and divide the number from step 5 by the number step 3. So in the step 5, we have to divide the number from step 5. That means the count of number data value 70 we have set, and there is we found that we imagine that there is 3 numbers before 70. So that means the left side of 70. So 3 is divided by the number of step 3. We already calculated the total number of observations, that is 10. So the percentile of that particular data set where 70 is set as the data value which we are interested to find percentile. Then we have to divide 3 by 10, which 10 is the total number of observation, 3 is the number of values that are lie left side of 70. So we get 0.3 as the answer. So 0.3 is the percentile of that particular data set. So it is easy to calculate percentile. So how it is important in measuring dispersion? The point, sorry, we have to multiply that with 3. Sorry, multiply that with 100. Then we get 0.3 into 100, that is 30. 30 is the percentile of that particular value. So we get 30 as the percentile of value which we imagine imaginary data set. So percentile calculation is easier. That higher percentile shows that huge dispersion, and of data set is present, while lower percentile value suggests that there is lesser dispersion for the data set. So dispersion is very important in the statistical context to represent the individual observations. By using statistics such as we already discussed range, standard deviation, variance, mean deviation, etc., we can see how spread data is. This is very useful in finance education and research. Ultimately, a thorough grasp of these measures enhance our easiness to analyze and communicate the data, leading to strong conclusions. So dispersion is very important in statistics in order to make informed decisions, to make robust conclusions, etc. So today we are winding up this session.